such various talks in future. Thank you so much, sir. Now I would request Professor D. Narayan Rao, President ISTF, to deliver his expert talk.
Presidential address, please read.
Yes.
The chief guest of today's function well-known scientist of international repute, a great son of India, and Secretary, Department of Science and Technology, Government of India, Dr. Chandrasekhar. Kindly give a big applause welcoming Dr. Chandrasekhar. Chancellor of Mohan Babu University, Dr. Mohan Babu, the Vice Chancellor of MBU, Professor Nagaraj Ramarao, the Registrar, Dr. Sarathi, Secretary of the Foundation, Dr. T. Narayan Rao, Mrs. Chandrasekhar, who is sitting in the audience, Dr. Ishwaraya, Chief Scientific Officer of MITS Madanapalle, Deans, learned faculty members of MBU and other institutions, bright, young, passionate students, hungry for ideas, friends and well-wishers from print and electronic media, elite of the Temple Town, ladies and gentlemen, I am glad to associate myself with this distinguished lecture being delivered by Dr. Chandrasekhar. Science and technology is all about innovation, discovery, and research. Indian scientists and technologists, with their insatiate quest, have made significant contributions in certain chosen areas of national priority and societal impact, given the resources allocated for science and technology. For paucity of time, I wish to make mention of a few outstanding contributions of Indian scientists in this country. India is designing, developing, and launching world-class communication and remote sensing satellites. These communication satellites have brought out sea change in our communication networks. India has launched a mission to Moon Chandrayaan, and it is an exciting story. One of the defining moments in India has been the roaring successful launch of Mars orbiter mission, Mangalyaan. The Mars orbiter mission has paved a new global pathway for interplanetary travel. Delhi jao, Kolkata jao, Mumbai jao, Hyderabad jao, Chennai jao, तिरुवनंतपुरम जाओ, ऑटो वाला किलोमीटर के लिए 10 रुपये लेता है। हमारे साइंटिस्ट ने मंगलयान को किलोमीटर को 7 रुपये में बनाया। हिंदुस्तान के वैज्ञानिकों ने अपनी ताकत को दुनिया को दिखाया। Now we are planning Gaganyaan, sending humanoids to space. All these achievements are accomplished by Indians trained in India. ISRO has not imported Smith or Jack. All these were achieved by Indians trained in India. The Indian nuclear program is quite significant. In the world, nuclear programs only of India and China are vibrant. Indian biotech companies have captured the vaccine field, and within a short time, India became the vaccine makers for the world. About 45% of the entire children's vaccines, which Dr. Chandrasekhar is well aware, and a part of these developments of the world are now made and distributed by these Indian biotech companies such as Shanta Biotech, Bharat Biotech, Biocon and others. 30 to 40 years back, India was a beggar for vaccines. And today, India is a proud donor of vaccines. We are donating vaccines to more than 100 countries. With all these achievements and contributions by Indian scientists, today the world is looking at India with admiration and expectations that we will continue to solving global issues plaguing mankind, such as clean energy, water remediation, clean environment, and sustainable growth. As you are all aware, science, technology, and innovation are the key drivers for wealth generation, quality of life, and national security. India is moving ahead on a sustainable development pathway for achieving Atmanirbhar Bharat, self-reliant India. The Department of Science and Technology, Government of India, is endowed and plays a pivotal role in promotion of science and technology in the country. DST promotes new areas of science and technology with special emphasis on emerging areas. DST has developed excellent research ecosystem in the country, in the universities and institutes through their flagship programs, Inspire, Sathi, SAFE, PERS, FIST, Women Scientist programs, and many more. The present edition being NRF, National Research Foundation. Wealth could be generated by addressing problems of the society and by developing needed technologies. Bharat Biotech is a recent outstanding example of wealth generation by developing the much needed and well appreciated Covaxin. In the inaugural address of the Indian Science Congress held in Bangalore in January 2020, the Honorable Prime Minister emphatically mentioned innovate, patent, produce and prosper. The Honorable Prime Minister Narendra Modi ji firmly believes that our future will be secure and our global scientists, global leadership will sustain only when we produce the next generation of world-class scientists, technologists and innovators. It is the endowed responsibility of universities, institutions and national laboratories to develop the world-class scientists and technology. I repeat, it is the endowed responsibility of universities, institutions and national laboratories to develop the world-class scientists and technologies. Universities are viewed as creators of new knowledge, innovative ideas, providers of skilled manpower, agents for social changes, symbols of international attention and prestige. When we talk of US, immediately we say Stanford, MIT. So thus, institutions command the prestige of the country. New technologies in the domains of advanced materials and nanotechnology, AI and ML, virtual reality, augmented virtual reality, quantum computing, digital technologies, biotechnology, blue energy, AI in drug development, healthcare and pharmaceuticals, electric vehicles, hydrogen-powered fuel cell-based cars, trains, buses, submarines, green hydrogen and green mobility will be the key drivers of growth. World needs highly skilled manpower, and India only can provide the skilled manpower to the world with 21st century skills. India produces 15 lakhs of engineers every year, which is about 8 times of the engineers produced annually from the entire United States of America. We all realize that these young students present here and many more in the country are the valuable asset of India and also asset of the world. Google, Microsoft, Yahoo, Facebook, Intel, IBM, and other international companies are looking towards these young, trained, talented, and bright Indian students. The active and vibrant presence of Indian engineers is seen very much in the global technology space. People with the degrees from Indian universities and institutions have made their mark in the Silicon Valley in the US. Illustrious examples being Satya Nadella, Chairman Microsoft, Sundar Pichai of Google, Arvind Krishna of IBM, and many more. Indian diaspora is our pride and are bringing laurels to the country. You look at any product coming from US, there is an Indian inside, like Intel inside. We are passing through exhilarating times. For the first time in the last 300 years, we have received the respect of almost every major country. This is because of superbly talented young people of this country. మీ ముత్తాత ఇంటర్నెట్ ఉంటుందని ఊహించాడా? మీ నానమ్మ ఐఫోన్ ఉంటుందని కలగన్నదా? తాత ముత్తాతల కలలో కూడా ఊహించలేనటువంటి శాస్త్ర సాంకేతిక అద్భుతాలను యువతరం సాధిస్తోంది, అవలీలగా సాధించి చూపిస్తోంది. అటువంటి యువతరం ఇక్కడ ఉన్నది. India is aiming at quantum jump and is not looking at incremental, because India is moving fast towards $5 trillion economy from the present $3 trillion economy. In the next few years, India could overtake the economy of Japan. India is politically independent and is fast progressing as economically independent. India also needs to be technologically independent. Universities, technical institutions, national laboratories have significant opportunities to contribute. India has emerged as a major economic power in the world, primarily as we made friendship with science and technology. COVID-19 pandemic forced us to realize that instead of importing, developing indigenous technology and manufacturing base should be the national priority. India has the capability to convert a crisis into an opportunity. The government of India emphasizes that education plays a pivotal role in human resource development and nation's economy. Thus, the National Education Policy NEP 2020 lays the foundation for new India over in the 21st century. Hence, the student knowledge, this is a request to the faculty members and university administrators that the students' knowledge must be flexible to cope with the 21st century jobs. Just tailoring the skills to the existing jobs which may disappear in the next few years is not the way. The National Education Policy 2020 will make India a knowledge superpower. Now it is India's turn. All of us know that our time has come. All of us know that our time has come. I'm very confident that our time has come and India is set to regain its due place in the Committee of Nations. India's G20 presidency will enable us to significantly contribute to some of the global issues of societal impact. During the last few years, Government of India has started several major programs such as Deep Ocean Mission, Blue Economy, National Hydrogen Mission, Green Hydrogen and Green Mobility, National Supercomputing Mission, Quantum Computing Mission, Semiconductor and Display Manufacturing in a big way, data centers and data localization, etc. These new and emerging areas will provide abundant opportunities to the younger generation, which earlier generation, including me, did not have. The younger generation, you sitting here, have abundant opportunities and work for it. Jai Hind, Jai Bharat, and Jai Vigyan. Thank you one and all.
Thank you, sir. That was quite inspiring. I could gather only one thing, that and miles to go before I sleep, and miles to go before I sleep. Both Mohan Babu University and India has miles to go before we sleep. We need not say. Before that, I would like to request all the student fraternity to restrict their movements, because we will be hearing to the eminent scientists present among us. I would request all the student fraternity to sit quietly at their designated place and restrict their movements. Thank you. We need not say about the chief guest. The whole campus is vibrating and echoing his presence. Dr. Chandrasekhar, Secretary to the Government of India, Department of Science and Technology. Let us all take the opportunity to wish him many, many happy returns of the day. Born on March 9th in 1964, Chandrasekhar completed all his primary and higher education in Hyderabad and joined CSIR IICT for a PhD program. After completing his PhD with the then director, Dr. A.V. Ramarao, he moved to USA for a postdoctoral position with Professor J.R. Falk. He joined CSIR IICT as a Scientist C in 1994 and grew up to the level of director in 2015. He is a fellow of all the 3 Indian Science Academies, National Academy of Sciences, Indian Academy of Sciences, and National Science Academy. He is also an Alexander von Humboldt Fellow. He has made significant contributions in diverse areas of organic chemistry, with a special emphasis on chiral chemistry, total synthesis of biologically active national products, and pharmaceutical products. He introduced polyethylene glycol as a novel, environmentally benign solvent medium. He has developed technologies for the synthesis of latest anti-tuberculosis drug, beta-choline, anti-tumor and abortive drug, misoprostol, antiplatelet molecule, betaprost, antidepressive compound, sertraline, and drug for treatment of schizophrenia, acinapine. He has more than 285 publications with 7,600 citations. 80 students have already been awarded PhD degree under his able guidance, and 20 postdoctoral associates have worked in his group. He has received several accolades, including Eminent Scientist Award for contributions in the field of chemistry from Telangana State Government in 2017, CNR Rao National Prize for Chemical Research 2012, CSIR Technology Award 2014, and Infosys Prize in Chemical Sciences 2014 for his contributions in synthetic organic chemistry with special focus on the synthesis of complex molecules from natural sources and innovative practical approaches to pharmaceuticals of current interest to industry. So the stage is now all yours, and we are all ready to hear from you. Thank you.
Am I audible? Super, okay. Good morning to all of you, and thank you for the birthday greetings. And while the projector is set and the slides start running through, I would like to thank the Honorable Chancellor of this university, Shri Mohan Babu Garu, the Vice Chancellor, also my dear friend Narayan Rao from SRM, and all the colleagues who made this event possible. And while I gave a title to you that Science for Planet's Well-Being, and I have a large story to share with all of you. And when I'm told that this auditorium has been divided into 3 verticals now, I think a vertical which has all the engineering faculty who left studying science after their 12th standard, and have young girls and boys in the middle who pursue science but are in a confused state whether they should pursue science or leave science and go to engineering or medical sciences. And I also have engineering students who are pursuing their studies here. So I changed the title from Science for the Planet's Well-Being slightly to a different story, Saga of Science. I, being a scientist, I only talk of science. I also talk of how science influences our lives and whether we should continue to do the science the way we are doing or we should change the way we have to do. Also imagine if a teacher is given a responsibility to address a classroom. There are some professors who know more than the teacher, so difficult to talk anything. Then you have young students, you can talk anything because they don't know too many things, so anything you can talk. Now there are young students, engineering students who are in undergraduation, they think they know many things. So it's so difficult today to tell the next half an hour. Maybe I try to do 35 minutes, 40 minutes, I don't know, depending on how it goes. And tell you the story of how science has changed our lives. Also I will tell how science plays an important role in the planet's well-being. When I say planet's well-being, many times my young students will think we are talking of a planetarium, we are talking of astronomy. I'm not going to talk of that. We all know that we live in the planet called Earth. Am I correct? So this is the planet on which we live. And we never make our house dirty. We all know that when you live in a small house or a big house, you make sure that your house is as tidy and clean possible. You don't make it dirty. You also don't like to keep stale food in the refrigerator, which stinks your kitchen. So we tend to be better than what a normal human being has to behave in your house. But the moment you leave the house, I think the journey begins for all of us, that we would like to throw the garbage on the road. I'm sure most of you who come from small towns and villages, when your grandmother or mother or your servant maid who cleans your house, they sweep in front of your house, but what we do is whatever kachra is there in front of us, we push to next house, and our in front is clean. I think that's how we operate generally. I think this is a mindset of us, unfortunately. But remember, if you are living in this planet, and if everyone is throwing their garbage onto the next house. For them, next house is the next country. Then the garbage is going to be there forever, and that's going to be the challenge to this planet. You also have been, I don't know if I'm standing here, are you able to see the slides? Okay. Otherwise, I can go a little away. So when we talk of the planet's well-being, we talk of, I know even high school boys and girls keep reading in the newspapers, the teachers keep telling there are some greenhouse gases. The biggest bad gas on this planet is carbon dioxide, nitric oxide, a little bit of sulfur dioxide. So these are the gases which we are all emitting because of industrialization, and these gases are spoiling our environment, and that is resulting in the global warming. You also must have heard that 1.5 degrees, again those who did not hear this 1.5, it's a magic number now. So if this planet's temperature increases beyond 1.5 degrees in the next 30 years, the prediction is planet may not be there. Because whatever Himalayan ice is there, Arctic, Antarctic, whatever ice melt, solids are there, they all melt and they all come into sea, and sea levels will increase and we will not have land to live. So that is why we always say that we want to keep the temperatures not go beyond 1.5 degrees increase. We are already start looking at increase of temperature in the last 70 years since Industrial Revolution. And those who study high school history, they know that Industrial Revolution has begun sometime in the 19th century, early 19th or late 18th century. And then we keep on increasing our comfort levels. So this revolution, what we call Industrial Revolution, was basically created for the human being's comfort. We are unfortunately the most selfish living beings on this planet. We are the only living beings on this planet who tend to keep food stock for next 1 year. Whenever there is a decrease in rice price or onion price or some price, we buy more than what we need, we keep in house. Then of course it is spoiled because of insects or whatever problems. But we are the only characters on this planet who tend to store the food. Animals, whenever they are hungry, they eat and leave it there. I don't think they take some food, keep at home, take it for 1 year and all that. So this is a very different trait we have. But if you also look at the entire generations of our lives, since the Homo sapiens, the so-called we were on the four legs, slowly our front legs have become shorter, then they became hands for us, then we became Homo erectus, we started standing a little bit, our vertebrae became straight, so we became Homo sapiens now. Am I correct? Those who study zoology, a little bit of science, I think we all know that we are Homo sapiens. And I don't know how many of you have gone back and looked at the dictionary. What is Homo sapiens? Homo is of course human. You know, sapien is a gentleman actually. Are we really gentle? Are we gentle? If we are gentle, then why are we spoiling the planet? I don't think no living being on this planet, no animal, would spoil the planet. We should know that even the largest animal which this planet has seen, dinosaurs, just because of one asteroid impact and the change of environment what we have seen, has disappeared from this planet and became an extinct species. And the way we behave on this planet currently, who knows, if not in 30 years, 50 years, maybe in 1000 years or 500 years, maybe Homo sapiens become extinct. So we need to be the well-wishers of the planet. You can be well-wisher of your own self because you need to be healthy, you need to be 6-pack, 8-pack, whatever all we have. But we need to be good, but we also need to consider the well-being of planet. So that's what I want to convey as the story progresses. And this slide is basically to tell you that whatever content I am going to share with you was an inspiration of a book called 21 Lessons for the 21st Century, an outstanding book written by Yuval Noah Harari, an Israeli writer. And he writes science, a history as a model, and builds the entire 21 lessons. So those who get some little time, they could buy these two books, Science and History and 21 Lessons for the 21st Century. Those who have little inclination to read some books. So science traditionally has been A personal activity, please remember again, this is not for young school children, but those who are in the faculty. Science cannot be driven by someone else. It has to be your personal passion, and you need to have few expectations, and scientists throughout history have applied their craft not through a lust for glory of material reward. Unfortunately, we're all driven by that. We're all driven by a medal, which is a material, unfortunately, and satisfy own curiosity about the way the world works. But we need to do the curiosity-driven science is something we need to push. So this is the definition again for my faculty and those who are going to be faculty in the near future, not for young boys and girls, but I'm sure they will understand it also equally well. What are the rules of a scientist? As you join this university or a college or a school, some rules are made. You should come with uniform, you should wear shoes which are polished, you should come on time. So there is an SOP written for all of us. Similarly, for a medical doctor, there is an SOP written. He should never ignore a patient, he should have compassion. Whether the patient pay the fee or not, first we should do the treatment. So these are kind of oath a medical doctor takes when they finishes the medical college. Similarly, engineering students will have their own boundaries against which. But unfortunately, scientists have not put any boundaries. Scientists believe that we are people from different planets, so we can do the way we like. Because science has to be freelancer. You need to keep thinking freely and do what comes to your mind. But there are also some boundaries which have to be made by the scientist. Scientists are the ones who have the maximum failures than anyone else. That we should keep in mind. For example, if engineer constructs 100 bridges and 99 are not there and they fall off, that means you are not a good engineer. If a doctor treats 100 patients, 99 die, that means there is something wrong with you. But scientist is the only poor character on this planet who does 100 experiments and 99 fail. So scientist has to have that mindset to accept that every day I'm going to do something is likely to fail, not likely to pass actually. So you need to be prepared for that failure every day, and suddenly one day you get that little success. Of course, learning is very important, and we also need to assume nothing, question everything. Scientist is something who needs to ask questions. If you're not asking questions, you should not become a scientist. A scientist is the one who keeps asking questions, okay? Then science is the fashion where whatever you know, you should teach. Again, a doctor will never teach a patient how to treat a patient because it's a trade secret. He will not get the fee. But here is the scientist who has to teach everything what they know. Then only science disseminates, and then of course, as I told, the planet will be much better off. Then analyze objectively, practice humility. Scientists are the ones who need to be with a lot of humility. Then respect criticism. Again, this is a profession where you need to accept the criticism. Your political leadership, your management will come and say, you are doing everyday experiments, I have given you so much money, everything is failing. But we need to convince the investors that yes, this is the profession where failures are more than successes. Take initiatives, that's very important for all of us, and ask tough questions. Never ask easy questions if you want to do good science, okay? And of course, love what you do or leave it. Many times we need to also see that if I don't like this science, I think we should not do it. But if you take the decision, I think you need to start loving it. I think these are some things which we need to keep in mind. So what I would like to share with all of you is, while we are talking of the planet has to be happy, but for the planet to be happy, we all need to be happy also, okay? For us, these are the three things which keep us happy. Am I correct? Because if you have good health, you are generally happy. And you are getting your food at the low cost, it's good quality, you are happy. And of course, always you are lighted with light, your energy, petrol is at the low cost. So this is the three things which drive our happiness. Of course, besides this, your mental aptitude to accept the happiness. So these are the things which drives the world's happiness, and these are the parameters which are given: GDP per capita, healthy years, social support, and all that. Generosity is something very critical. So this is something which makes you more happy. You give something to others. That's what science is, something which tends to give whatever we do to the world. So that's why scientists have to be more happy, according to me. And of course, environment, social, urban, these are some of the parameters which make us happy. But unfortunately, we don't, India don't appear in the top 10 countries of happiness. I think we appear somewhere around 100 out of 150 countries. So my young friends, especially I think the school children are in the middle rows, I think start learning how to be happy. I think that's something very, very, very important to all of us. So we also know that, like the planet, I think when you know that this whole universe was one piece, but after the Big Bang, we started getting the fragmentation of the Earth, the land, the other planets, also, or your Milky Waves, and all this is because of a bang which happened, which you study in your physics, okay? So, but when this planet was formed, we should know that there was no country called India, or there's no country called America. It is one piece of material. It's a material which is called Earth. And then it has ocean on that. But then we as human beings have started dividing our planet into smaller pieces, like United States of America, or India, or Pakistan, or China, or whatever. So we made this planet into a fragmented planet, okay? Similarly, we the scientists also were not content with what we do, and then we started looking science as a fragmented piece. You are a physicist, I am a chemist, you are a botanist, you are a zoologist. Within botany, you say you are a paleobotanist, I am some advanced botanist, I am a geneticist. So we also divided. So what happened in the process is, we built into too many super specialities, and which takes back to an anecdote of our health profession. Now we don't see general physicians. You get small chest pain, you go to a doctor, first you think chest matlab, you should go to a heart specialist. Heart specialist only knows that heart has to be checked. He will write you whatever required for ECG or whatever is required, and then he keeps looking at heart, not realizing that this chest pain might have been because of an acidity problem in the stomach. So unless we have the general physician concept to understand your whole body. Similarly, in science, unless you know whole science and impact of each subject, will not be able to see the whole problem of the planet. So what I suggest is, when our young boys and girls start reading science, don't fragment yourself into, I have a lot of interest in physics, within physics I have a lot of interest in astrophysics, within astrophysics I only want to study Mars or Jupiter, within that also I want to see what element is there on Jupiter. So we become narrower and narrower and narrower, and then we are not able to see the holistic problem. So when you start reading science, read science as a holistic science. Don't read as bits and pieces which you like. Otherwise, you will not be able to be a good citizen of the planet. Okay? So this is all I'll leave story. But remember, when we all want to be celebrities, no? Basically, when I walked in, I saw my photograph on a poster. Narendra Rao's photo was also there, I think. So, thank you, Narendra. So we all feel happy that someone has put my photograph on the wall poster. And of course, we are part of Mohan Babu University. He himself, the chairman of this university himself, was a celebrity. He was always on the posters. And people used to go and take autographs and whatnot. But remember, whatever profession we choose, those professions are very short-lived. If you take sports as a profession, you know, when Narendra was young, he was looking at Gundappa Vishwanath or Sunil Gavaskar, which you never heard the names. We forgot. He also forgot. We all forgot. After some time, we started looking at Sachin Tendulkar. We also forgot him now. I don't know anyone will remember Sachin Tendulkar, who was the blaster of cricket, all that. Nothing we forgot. Then we looked at Virat Kohli. Now suddenly we all protest. Virat Kohli should remove the team. We need a new fellow now. Am I correct? So these are all like 5 year, 10 years, 8 year stories. But remember, these are the permanent poster boys. You open any textbook in the world. So these are the people who become eternal on the posters. Poster is a textbook for us, okay? So we would like to emulate, I want to be an Isaac Newton, I want to be a C.N.R. Rao, I want to be an Abdul Kalam. Then I think whatever little you do will be there as long as this planet is there. So I'm happy that you're all in this audience trying to be understanding what is science. Again, I'm not segregating science and engineering. Without science, there is no engineering. And without engineering, there is no science. Because whatever little innovations you do in the laboratory of a science, an engineering or technologists will take them forward, refine them, make a product. So I think both have to go hand in hand. So these are our poster boys. Okay, so not something else. So when we look at the beginning of this universe, as we have been talking of our planet, but our planet is just the smallest of the tiniest of the particles of this entire universe. We know if you look at the entire universe, there are so many stars which are much larger than the sun. And sun itself is smaller in all these galaxies, and imagine Earth must be much, much tiny. It's like a small dot on the whole universe, okay? So, but then the entire science journey has begun, and this physics and astrophysics are the areas which were the earliest sciences. The first scientific observations were the sky, stars, planets, comets, supernova. So Copernicus was called, he described the revolution of celestial bodies, establishing the revolution of planets. Then stars as distant suns, there is no center to universe. These are all the philosophies which were given by these scientists. Okay, and imagine Tycho Brahe, he was called the naked eye astronomer. If you have concentration, when there was no telescope, he was the person to look in the dark night, look at the sky, and figure out how entire stars and planetary motions happen. So this is how the entire astronomy and astrophysics have begun, so without any tools. So they did not go to DST or they did not go to university, got some grant. He just went and saw the naked sky. So scientist has to keep his eyes open. But unfortunately, many scientists keep their pockets open so that they don't need more money, more grant, more grant. I think we need to open our eyes and look at the planet, observe, and then the science will automatically evolve. Okay. Similarly, these are some of the path breakers. Kepler's law we all study in the school, then Galileo, how he has made the entire astronomy more, and then telescopes are built, now we have lenses. And remember, India is now going to build a 30-meter telescope in Hawaii Islands in partnership with some international collaboration. We are working with them very closely. We built a 5-meter telescope in Jammu and Kashmir. So basically, these telescopes are to look at other planets, what is there, whether I can take advantage of what is there in other planets. So studying other planets while we are worried about our own planet is also very important, and this science, astrophysics, addresses these challenges. Similarly, if you look at entire biological sciences, how it began 1635, there was a boy called Robert Hooke. They say that he will not survive because he had a lot of genetic problems. He cannot digest the food, he has to live on milk and fruits. But imagine he went on to become the most famous discoveries of Hooke include cellular structure of slices, structure of feathers, nature of butterfly's wings, compound eye of a fly, all these things, someone who was physically not sound. So sometimes you don't require to be physically sound, but mentally sound to do good science. Then imagine looking at one of our own, Shushruta, who has made surgeries possible. Today we all know that the medical doctors have conquered the heart. If a small problem happens or a major problem happens to heart, now heart can be removed from the body, heart transplant can happen, or keep the heart on the machine, repair it, put it back. So this kind of science has happened because of Shashruta, who made the first surgery in our country, who has shown to the world how surgery can be done. And imagine how they were doing surgeries. They were, actually, if you look at Vasella in 1514 in the US, in Europe also, founder of human anatomy, published many books. Gabriel Fallopi studied inner parts of the ear. Then William Harp worked on circulation of blood. So they're all studied by these scientists, which opened up the entire human anatomy and other sciences. And also remember this Sashruta, when he wanted to practice surgery, no one would go and say that you can do surgery on me. So what he would do, he would go and steal the dead bodies and then practice surgeries on that. So that's how surgeries have become today, saving the lives, but the risk he has taken to go to graveyards or going and taking some dead bodies, doing surgeries without taking. So these are all the innovations which have happened because of the great scientists like them. So chemistry is next subject, which is relatively younger compared to physics and biology. But chemistry has its own origins. If you look at the entire universe, I'm not even talking of this planet, entire universe is chemistry. You go to Mars, you go to Sun, you will see hydrogen, you see helium. In Mars, you see some other phosphorus. That's why it's red in color. Maybe you go to our own planet, we have entire periodic table. So many elements are there on this planet. So chemistry is something which encompasses the entire universe, not just our planet alone. So chemistry is some science which everyone has to have some fundamentals of how it works. So history of metallurgy is something which was the primary beginning of our science. And metallurgy has given to sword, then copper era, bronze era, whatever you see, all this is because of the innovations in chemistry. Okay? And I will not talk about how organic chemistry, which I practice, has evolved. But if you look at how our healthcare is taken care, you look at Paul Ehrlich, who got Nobel Prize in 1908. He proposed certain dyes could selectively stain bacterial cells. Again, those who study college biology, again, I'm sure some of the science labs would have, you will have a small slide, you put some red dye, and you see how the stain happens. Under microscope you see. Okay. Here is a gentleman who was trying to do a similar dye chemistry, and when he applied this dye, he found that some red color was happening on his slide. So then he gave a philosophy that this dye is selectively binding to the bacteria on his slide, and that bacteria is not replicating again. So now he thinks, okay, this is something which can cure infections. And then imagine next scientist, Domac, who also went on to administer protonsilate dye when his daughter was suffering from streptococcal infection. So it's a prodrug that releases this drug, and this drug is based, chemotherapy started from there. But imagine this girl became red in color when he gave this medicine. But there was no clinical trials those days. His daughter is suffering from infection. He thought, anyway, if she will die if I don't give any medicine, there's no medicine. So let me apply this dye to her. So he has put this dye. She became pink in color. She survived the infection because the bacteria did not grow. That has opened up the entire antibiotic research in the world. Besides Ian Fleming's observation of a petri dish where he saw that bacteria was not growing in some colonies, and he went on to discover penicillin as an antibiotic. Imagine this world if antibiotics were not there, maybe most of us would not be here. Remember when our industrial revolution began, the world average age expectancy was much below 50. Today we claim Indians live up to 71 years, 72 years. French people live up to 87. Japanese live up to 90. And who knows, we also start living 100 years. And all this was possible because of these accidental innovations which happened in the labs. Lab accidents are very common. We keep observing new things. But if your eyes and brain are not open to see that change, Fleming would have thrown the petri dish, we would have never got penicillin. But he thought why it is not growing. That's why I said, ask the question. He asked the question, why the petri dish, the agar, whatever he is growing, why it is not growing in the colonies. That triggered him, maybe some chemical is there which is not allowing it to grow. What is that chemical he went on to serve, which is penicillin? And he says that if it is not allowing, whether can it work as an antibiotic if I get infection. So that is how he planned stepwise to get an antibiotic for all of us. I can also tell you, when recent Nobel Prize, again this is little high science, those who study analytical sciences will know, mass spectrometry is an important tool in chemical sciences to understand the molecular weight of any chemical. We all know that carbon dioxide molecular weight is 44. Am I correct? Oxygen is 16. So 2 oxygen is 32. Carbon is 12, so it is 44. But how do you know? You can inject this into a gas chromatography or mass spectrometry, it will give you the 44 peak. So this mass spectrometer was not able to detect some very complex inorganic materials. And one Japanese scientist, on a Saturday he was doing experiment, he did not find a small test tube in the lab. Then he had an empty bottle lying in one corner. He took that empty bottle from the dustbin, he opened the cap, and that cap he used as a test tube. So he put all his chemicals in that cap and then he injected into the mass spectrometer. And suddenly the eureka moment has come for him. And then he found that inorganic complex, which is very big polymer, the mass peak has come. He was shocked. But then he analyzed what experiment I have done that today my mass spectra is showing this peak for this matrix. Then he found that the empty bottle what he was using was an ethylene glycol bottle. And that cap had 1 drop of ethylene glycol. When he made the sample, that ethylene glycol impurity has allowed the mass molecule to fragment into pieces. That's why it's called Maldi's assisted laser spectroscopy. So an accidental observation allowed him to open an entire area of how you can study mass, and he got Nobel Prize for that. It's not that had he had test tube in the lab, we would have never got this innovation. So sometimes not having things is a blessing. And only last week we celebrated Raman innovation on February 28th. Imagine if Raman spectrometer was there, some spectrometer was there, Raman would have never built that machine. But because it was not there, he was a scientist in Calcutta, one of the DST institutes, Indian Association of Cultivation of Science, and there he built this Raman spectrometer, and then the history is written. India's one Nobel Prize, which was made in India, was Sir C.V. Raman. So you don't require huge equipment, big lab to get innovations. I think it needs again the mind and how you observe this universe. Okay? So we all are happy sitting and without mask today is because of the vaccines. And if vaccine was not there, most probably this pandemic have put all of us off. I don't know any of us would have been surviving or maybe die. We don't even know what would happen. But again, how observation by an individual, you don't require to be a scientist to observe. Here is the vaccine development, smallpox vaccine by Edward Jenner in 1796, BCG vaccine 924. You can look at how the vaccine evolution happened over the period. But when one shepherd who was taking care of the cow, to milking and all that, he was observing that those cows which are infected with cowpox, and those shepherds were not getting this infection. So he realized that close proximity with that exposure to small virus is enabling those shepherds to get immunity against this infection. And that has opened, and then we started getting the cowpox vaccine, then we got chickenpox vaccine, we have smallpox vaccine, which we eradicated totally, we have polio, which we eradicated, COVID, more or less, we eradicated. This small observation by a shepherd community was able to produce the entire science of the vaccine research. And I'm happy when Narendra was making comment and also introduction. When we got COVID pandemic, IICT was an institute which worked with Bharat Biotech closely when that Covaxin was made. Imagine Honorable Prime Minister has taken Covaxin because he believes in made in India product. So he was the one who, after the clinical approvals, he was the one who took the vaccine. And each vaccine will have a chemical called adjuvant. And we were able to make this adjuvant for all 30 crore doses of Bharat Biotech vaccine in IICT Kilo Lab, which enabled all of us today without mask. So how the vaccine research and chemical industry put together was able to make sure that this pandemic has gone away from us, okay? And as I told, our age expectancy keep going, but we need more and more materials and we need to work on that. So when we are talking of health, now we know that how the health has taken care of us. But agriculture, also this is the history of agriculture. Imagine when several millions of years ago, when human being was there on this planet as a Homo sapien, there was no agriculture. We were hunters and gatherers, okay? Which you can always see in the history of human being. So you hunt an animal and eat that raw meat and go from one place to other place. So that's how human has started moving on. But then when human beings started finding less and less of animals around, they started eating whatever plants are available, going on to the plant, eating some fruit. So that's how slowly we can also eat a fruit and leaf and survive. And the story of how people started cooking meat, there was a wildfire in the forest and some animals have died. So some lazy human beings who had no energy to go and hunt an animal to eat a fresh meat, so they picked up whatever was charred meat in the forest fire. And they realized that that meat was little more tastier and digestion was better. So that's an observation. So that's how entire cooking has come up. Otherwise, there was no cooking for all of us. So again, an observation by a human being who saw that there's a forest fire, the meat burnt in that forest animal death. That meat was tastier, easy to digest, and that has opened up the entire cooking concept of this planet. Okay, but then vegetarians also have to collect, so they become gatherers. So they gather all the vegetables available, and then slowly agriculture began. And you can look at how the entire Egyptian Nile River, Indus Valley culture, the Tigris River culture, all this across the rivers, the Homo sapiens was moving and started growing some agriculture together. And that's how the socialism of what we believe today and all that culture of countries and units and all was the beginning of agriculture actually. Now, you look at India also had big famines some time ago, and we were able to take the technologies of Norman Borlaug, who got a Nobel Peace Prize, and Swaminathan, to get the green revolution, which got new varieties of paddy, new varieties of wheat, which gave us more crop per acre, and we were able to get food security for us. Okay, and then of course the evolution began with small farmer to tractor to we are going to drone technologies now, and those engineers who are working on electronics, mechanical engineering, they work with the farmer today, they work with agricultural scientists to build the drones. So drones are going to be the next game changer for the agriculture industry. Okay, so these are all little bit of agriculture, and if you look of other engagements of farmer is crop alone will not give him enough food. I'm sure most of you coming from some farmer communities, agriculture alone will not give you enough revenues for the family. So parallelly, other cultures like aquaculture, agroforestry, all beekeeping, I think these are all the things which started part of the agriculture community for energy security, agricultural security, food security of our planet. Now, if you look at the meat, who are non-vegetarian, you can also imagine how the hybrid varieties of crop has allowed us to grow, as I told you, Norman Borlaug and Swaminathan. Same technologies were used by the animal scientists, and see how a chicken was looking in 1947. Now you started hybridizing, and then the size increases. So the size becomes so large, it may be someday as big as a dinosaur. Then dinosaur can cater to all of us. One dinosaur will give meat to all of us. But will it allow you to kill? Maybe it will eat all of us and go away. So this hybridization technologies, while the size increases, the nutritional quality, that is where you need scientists who work in nutrition. When I do hybridization, whether my second generation, third generation, food or meat will have the enough nutrients, especially the micronutrients, which play important role. That's how the entire science of nutrition has evolved, and that keeps you healthy. So today when we talk of holistic health, again those who are following up Honorable Prime Minister's message for G20, I think which Narendra was referring on. Now India got presidency on G20, and we are advocating to the world that don't go to your doctor after you get the disease. First, how do you prevent the disease? So starting from good practices of yoga to meditation, to good practices of morning walk, healthy diet, micronutrient concentration is properly taken, iodine salt is taken properly. So if you really take proper nutrition, you don't require the health care to be so much burden on the planet. Of course, if it comes, then naturally we need to go for the health sector. Okay, so these are some of the new technologies happening. Smart protein, as I told, your meat plant-based. Now your vegetarian need not worry that, I'm not eating a meat, okay? So it can be plant like soya, or chickpeas and all are made in certain formula to look like it gets the meat texture. Similarly, meat can be grown in the lab using fermentation and also cultivation in the lab. So you don't require to go and grow the animal size, but still you could make. This is going to be a big changer in the food security for all of us, especially in the meat, okay? Now, which I spoke in health a lot, but I'll give you one or two quick examples. where we talk of one molecule. Again, this is something very advanced science, but the message I wanted to convey to you is, please read the name Dr. Suren Sehgal, okay, an Indian scientist working in Canada. There was one chemical in his lab, okay, and they found some properties. We all know that a chemical will have some property. But the company became bankrupt, and the company management said, now just throw that chemical in the garbage and vacate the refrigerator and all that, said you lost your job. Everyone lost the job in the company. But he was the one who slowly took away that sample without telling the management. I'm not preaching you should steal something, but he took the sample. He believed that this molecule is going to be a game changer. So he took this chemical out, joined another company, and built this chemical which became rapamycin. And this is the molecule I showed you here. Very complex organic molecule, okay? But imagine this molecule plays a role in cancer, treating sclerosis complexes, then brain lesions, Alzheimer treatment. You name it, has become a blockbuster. It's also an immunosuppressant. We all know that when a kidney or a heart or lung transplant happens, liver transplant happens, what happens is our body rejects. Whenever a new organ is implanted, it's rejected by the body. So the cyclosporine and rapamycin are the two chemicals which reduce your immunity so that your body does not reject that. So imagine a chemical which was supposed to be thrown in the garbage went on to become a lifesaver for all of us, okay? And then we talk of agriculture. You know, agriculture, farmer needs a lot of urea. Again, in chemistry of high school, I'm sure engineering students in their first year of college also, they study a lot of chemical sciences. Urea is the lifeline. If urea was not there, I'm sure most of us would have died of hunger. Because of urea innovation by Oler in Germany, today our crop yield has gone up because it gives you nitrogen fixation. But imagine urea is now 3,500 rupees per bag, which farmer cannot afford. So we need to develop science which makes ammonia, carbon dioxide under pressure at high temperature, giving a urea has to be transformed, okay? But remember, this urea is also a competition now for Euro 6 vehicles. Those who drive Euro 6 diesel vehicles, they AdBlue is a chemical solution which is added into the engine. So the rich people are competing for urea now. Urea is supposed to be not so rich farmers. Now rich people who want Euro 6 car also consume urea. So we need to see how urea can become more and more cheaper and affordable so that we can get our foods also cheaper. So I'll not talk about the diseases which we get. Malaria is something, many people die of it. Another message for young students here is again on the artemisinin. We know that India still has malaria, especially if you go to Odisha, Srikakulam, some parts of even Andhra, Telangana, we have malaria. And this lady from China won the Nobel Prize in Physiology for discovery of artemisinin used for malarial treatment. Malaria has only one drug, okay? Chloroquine. We all know that chloroquine is the only drug available. But now malaria got resistance and chloroquine doesn't work and people even die of malaria. So she was able to discover. But the message of her, she gathered all the traditional Chinese medical data to get 640 prescriptions, out of which one was that molecule which saved all of us. So someone who is working on plant sciences, Ayurvedic knowledge, I think this is time we should partner with them and see how we can take knowledge out of our traditional knowledge. But the larger interest is she was deputed to work in isolation and identification of new scaffolds based on this medicine. Her daughter was sent to a boarding school and could not meet her till to accomplished her task. How many of us can go to lab, our children are in the boarding school, after 20 years I discover my drug, whatever I want, come back and your daughter will not recognize you, nor you recognize your daughter. So that commitment gave her the first Chinese citizen and a woman to get Nobel Prize. So this is an inspiration for all of us, okay? Then we did some work on malaria. I will not bore you with all that. And we have tuberculosis, yet another major problem which keeps bugging on us. And the 2-3 minutes I need to close up actually, okay? So tuberculosis is something which we all are worried after COVID pandemic. So we also would like to make new drugs for tuberculosis. Then my group has worked for some time and made some drugs on tuberculosis, which I will not bore you, which is all for high-end chemistry. But then during COVID, we were able to make some new drug called favipiravir, remdesivir injection, which saved many lives, and also the vaccine, what I showed with you. So again, this shows that the collaboration between a chemist, a biologist, a chemical engineer, a mechanical engineer, this combination only could bring in drugs to all of us, okay? Now coming back to energy very quickly, we all know that sun is the first source of energy, and then we went on to go, wildfire gave you the wood burn, then we have candle, we have kerosene lamp, now we have LEDs and all that. So that's how entire light. But imagine again, you need to know how fire was discovered by the human being. So fire is a discovery rather than invention. Remember, it's not a discovery, okay? It's a discovery, not an invention. Most likely given to a man as a gift from the heavens when a bolt of lightning struck a tree or a bush, suddenly starting the fire. And as early as 400,000 years before Christ, fire was kindled in the caves of Peking man. He was the first man to use the fire. And they used to save fire in a cave. Whenever you want some fire, you borrow from someone and do, unlike you borrow matchstick and all that. So that's how the fire was spreading across the communities. So, but then we know that wood will not be there, petrol will not be there, diesel will not be there. So next will be wind, biomass, hydrogen, solar, geothermal, tidal, and of course hydrogen continues to be the fuel of the future. So those who study, again, electrochemistry, they know that if you take water, do electrolysis, electrochemistry, and you can get hydrogen and oxygen. So this is the cleanest way one could get the fuel so that you don't burden this planet. When you burn diesel or petrol, a lot of carbon dioxide come out. So carbon dioxide will go, our greenhouse gas are emitting, and we get the challenges of global warming. So hydrogen is going to be the cleanest energy, but certainly we need to make sure that we need to be good human beings before we do any of the science. I only tell you there was a Tesla story, again in that book of 21 lessons for the 21st century. We all know that we are dreaming to have a Tesla car, those who study automobile industry. Because this car can go without a driver. And you write a program, sleep in the car, and it can take you wherever. But remember, the program is written in such a way only to understand the traffic rules. Okay, it does not know how to break the traffic rules. For example, if you buy a Tesla car and then a school bus is coming in a wrong direction, but you are in the right direction, but Tesla car believes that I am in the right direction, I am not going to apply the brake. Okay? Because it is, that's how program is written. You are not supposed to break the rule. That's a program written on that. But then you go and hit and then you may die or children will die and all that. So now the author predicts there will be two cars. One is Tesla Altruist, which is a gentleman car. So even if the school bus is coming, the rule it breaks. It takes a diversion even though you're hitting a tree or something. You will die. But the school bus will be saved. Okay, that is called Tesla altruistic car. But there will be an egoistic car, which says that let heavens fall, I am going to hit the school bus. Because I may survive, because I have all the balloons and all that, so I will survive. So which car you will buy? Are you sure? Okay, so imagine if you start thinking of artificial intelligence, and we all are hearing of ChatGPT now, while again the school children, I'm sure you are not getting access to high-tech as on today, but the moment you start getting into these technologies, you can ask ChatGPT to write my exam and you can sleep and it will write your exam. Or ChatGPT may say, even the master will say, I don't want to set a question paper now, it takes so much time. ChatGPT, please take 2009 to 20 all question papers, read them carefully, make a new question paper, and give to students. Your job is over. ChatGPT will make a question paper. So are we going towards a place where human will not have any role to play and even computer starts thinking for you? If that's going to be the world we will see in the next 5 years, I thought it will be after I die. But look like it happened already. I was in Cambridge University a few weeks ago. The faculty are worried there. how ChatGPT is going to take over. And now Google is coming with their own version, others are coming up. So this is going to be how we use AI, machine learning for the planet's well-being. I think that question we need to keep asking every day. And of course, sustainability is something we talk, but that's not the, this is my last slide. So when you look at history of science, I told you a little bit of how the surgeries have evolved, how astrophysics has evolved, how antibiotics evolved. It's always important to study the history of science, which is essential to understand the processes, trends, and also tell you how you should plan your future for human well-being, planet's well-being, and universal well-being. Thank you.
Thank you, sir. Your talk was an eye-opener. Different avenues. A big round of applause. Thank you, sir, so much. It was quite inspiring, an eye-opener that amidst all the challenges, a scientist takes the toughest road to prove its worth. Before we move on to the vote of thanks, we have a small felicitation ceremony by the ISTF, the foundation. Quickly we will complete that, and then I would invite Dr. K. Sardi for the vote of thanks, before we move on to that. Please be seated. Please be seated. Thank you. Big round of applause, please.
Just now, we heard the excellent talk by Dr. Chandrasekhar. He has hypnotized everybody here. I thought we should have done it as a public talk in Tirupati with 5,000 delegates. We will do that. So, as a token of our appreciation to Dr. Chandrasekhar, Innovation, Science and Technology Foundation would like to present a memento to our chief guest, and I request him to kindly accept.
Thank you, sir. May I now request Thank you, sir, once again. Yeah, may I now request Dr. K. Sardi, Registrar, Mohan Babu University, to deliver the vote of thanks.
Good morning, all. I, Dr. Sardi, Registrar Mohan Babu University, feel it honored and privileged to propose the vote of thanks on this special occasion. I am very much thankful to our Honorable Chairman, SVT, and Chancellor, MBU, Dr. M. Mohan Babu Garu, and revered CEO, SVT, and Pro-Chancellor, MBU, Mr. Vishnu Manchu Garu, and the Executive Director, SreeVidyanikethan Educational Trust, Sri Vinay Maheshwari Garu, for providing us with the world-class infrastructure at MBU to organize the events like this. I, on behalf of the MBU, convey deep regards and hearty thanks to the Secretary-DST, Government of India, Dr. H. Chandrasekhar Garu, for enriching us on the science for planet well-being which is connected to the contemporary theme of National Science Day 2023, Global Science for Global Well-being. He enriched us on the science, engineering and technology, how it is takes important place in the day-to-day or routine life. I'm also very much thankful to Professor D. Narayan Rao Garu, President, ISTF, Tirupati, and Dr. T. Narayan Rao Garu, Secretary, ISTF, Tirupati, who helped us to host this distinguished lecture. Words are not enough to thank their constant guidance and support to shape this distinguished lecture. My sincere thanks to Professor Nagaraj Ramarao Garu, Vice Chancellor, MBU, who made it possible in organizing this event in a grand manner at our campus. I would also like to thank Sri B. Ravishekhar Garu, Director Finance and Administration, SVT, and Mr. Nagaraj Raipati, Assistant Director, VC's Office, Vice President, Administration, Colonel Rao Garu, Dean Student Affairs, Arpita Basak Garu, Dean Planning and Monitoring, Naishwar Prasad Garu, who supported in all possible manner to organize this distinguished lecture. I'm thankful to all the deans, associate deans, vice presidents, associate vice presidents, program heads, faculty and staff of MBU for their help and support at various stages in organizing this event. I would also like to thank the representatives of print and electronic media. Without you, this event was not possible. I especially thank to Dr. A. Srinivasulu, Dean RI, Dr. P. Giridhar Reddy, Dean RA, and Dr. Vishnu Prashant, Associate Professor, BSNH, for organizing this event for successful outcome. Last but not least, I thank all the students for showing their interest in this event. Finally, I'm very much thankful to the organizers for giving me an opportunity to propose vote of thanks. I once again thank everyone for making this program successful. Jai Hind, Jai Bharat.
Thank you, sir, for the vote of thanks. Now the program has come to an end. Thank you, sir.